Today we are going to learn a coding technique called the scrolling background that will help give our graphical programs a little more excitement. I want you to write this down in your student journal for lesson 3.5. Again, we're still in 3.5 on animations. The scrolling background is a background that appears to be constantly moving in a certain direction. We're going to use this technique when we want to create the illusion that the background can move forever, but we obviously can't have an image that is that large. So if we wanted to create a game or an animation about a character like an endless runner game that's running for a very long time, often that runner or that character moves in the up and down direction, but in the side to side direction the character stands still and the background moves behind them. Scrolling background looks a little bit like a screen or a camera that's moving, but it's actually done by using a background sprite. Because the backgrounds are actually sprites, that means that they can have X speeds and Y speeds as well. So there's a lot of images that are in the Techsmart system that are already labeled as scrolling, and if you go through there you'll notice that they're a lot wider. Matter of fact, they're very specifically formatted so that they're twice the width of the standard window, so the 1080 times 2. But in addition to being twice the width, they're also mirrored so that one image looks like it's just been tiled, tessellated, or repeated after the other image. So what we do is we let the image scroll from right to left across the screen, or from left to right, either one. And when it gets an entire width off of the screen, we reset its position back to the original position. So we're going to switch over to our code now. We're going to open up the long drive program. And we notice that the long drive program already has a couple of images here. We have blue sports cars there, and then night street scrolling. And if you click on that night street scrolling, you'll notice that its dimensions are 2036. That's the standard window width times 2, and that's very important. Okay. Let's close that project window so we have a little more room here. So right now, if we run that program, we have our car is sitting on the roadway, and we don't want the car to move. What we want is the scenery in the background to move behind it. So if I make the background scroll, I can give the background, which is called BG, it's created right here on line 14. The BG can have an XSpeed property. So BG.XSpeed equals, and then I'm going to give it a negative 50. And we just want to see what that looks like. So it's a nice casual stroll. I want my sports car to go a little faster than that. So let's go negative 100. Okay, even a little faster than that. Negative 150. Not bad for a start. But notice what happens. We look all great and it looks like my car is moving, but then all of a sudden we get to the end of the double image, and then we say goodbye to our background. So kind of like when we turn the characters around by checking their width, we're going to do the same basic thing in this while loop. So as long as our window is running, we want to constantly be checking to see if the background has gone out of bounds. And by out of bounds, I mean that it has gone exactly one window width too far. And the way we're going to do that is in an if check. So I'm going to say if bg.x, the left edge of my animation, is less than or equal to one negative window width. That means it has gone one window width too far to the left. Then I can reset the background's x to its original x, which we see on line 14, its original x was 0. And I'm going to speed it up even a little bit more. Let's go to 250 so we can watch this go. So by this time last time, we'd already encountered the edge of our screen, and what we know, because of the way the image was created with that mirrored seam, we don't even notice that it happens, because instantly, in 1/30th of a second, that background goes all the way from the far left to the far right, And again, because of the way the image is seamed together, it is invisible to the user. Now, if I want to make the background go the other way, so I can say, this is going to look really weird unless I flip my car. So let's flip my car around too. So car.sprite, car.scale. Let's come here and say car.flipx equals true. There we go. So if I don't flip the car, going the other way is going to look really weird. But background x speed equals 250. Well, we're out of bounds already, because what we want to make sure, if we're starting in that direction, if we're going that direction, we don't want to start at 0. We want to start at negative window width. We're kind of reversing the algorithm. Okay. But we go out of bounds really fast, so we can actually go negative window width times 2 if we wanted to. Or we can leave that at 0 and adjust it here the same way. bg.x equals negative window.width. So either way you do it, it's going to set it the same way. 2 lines, 1 line, however you want to do that. And then in our if check, we want to change this if check so it's not looking at the left movement. We will say if the bgs.x is greater than or equal to, so remember the x is the far left side. So if I go all the way to the window width and I say bg.x equals negative, which is my starting, it's going to reset, but not until we get a full screen of white. So I can do a couple of different things. I can say when the bg.x is less than or equal to window width. I can subtract, but I'm going to say I'm going to take advantage of the fact I know that that is a double width. So since I started my background 1 width off to the left out in the middle of nowhere, when that comes across and hits the 0, I know it's time to reset. So instead of letting that go to the window width, I'm going to stop it at 0. So left to right mathematically is a little bit easier, but right to left is just a little bit of a reverse of your algorithm. Alright, that is it for the scrolling demo. Keep that code handy, save it, and know where it's at.